Before we get started with our new lesson, we're going to back up and we're going to quickly refresh vertex form again. So just as a reminder, our vertex form is y equals a x minus h all squared plus k. And our a, h, and k are responsible for changing how our parabola looks. So just as a reminder, a is responsible for two things. A is first responsible for a reflection. So if our A is negative, we should expect that our parabola is upside down or is sad. So if it's a negative A, it's a sad parabola. If it is a positive A, it's a happy parabola. And the proper terminology for this flip of our parabola is a reflection in the x-axis. So again, if our A is negative, it has been reflected in the x-axis. Secondly, our A is also responsible for our stretches and compressions. So if we're going to change the actual shape of our parabola, we will have an A value. And when we're looking for our stretch or compression, we are looking to see if the number in front of our equation is greater than 1. So remember for this, we're looking at absolute A, which means that we do not look at the sign. The sign tells us about the reflection, the actual number tells us about our stretch. So remember, if A is bigger than 1, then we have a stretch. So if I have 2, 3, 4, something like that, it's going to get tall and skinny, like I grabbed it and I stretched it out. The alternative is that I have a number that is between 0 and 1. So for example, I could have a half, a quarter, 7/8, 0.2, something like that. And if I have a number like that, it's been compressed. So this means that our graph should look shorter and wider. It's as if I took my hand on top of it and squished it down. Next, we have our h, and our h is responsible for our horizontal translation, or moves left and right. It is helpful that it is an h, so you can remember h horizontal and help that stick into your brain. Now, h can be a little confusing and a little counterintuitive to understand what it does. So, if h is negative in the equation, it's going to move right. And the reason it's like that is because of that negative in the equation, but this will always happen. So if in the equation I notice that it's negative, my whole parabola is going to be picked up and moved over to the right. If h is positive in the equation, my whole parabola is going to be picked up and moved to the left. Finally, our k. K is responsible for our vertical translation. That's the proper terminology for that. And if k is positive, it moves my whole parabola up. And if it's negative, it will move my whole parabola down. So k is not counterintuitive. If it's positive, we're moving up. If it's negative, we're moving down. So now what we're going to do in this lesson is we're going to be using those facts to try to graph this by hand. So before this, we have done some graphing, but we haven't been graphing it by hand. So we're going to use all of those pieces and we're going to try to put everything together. So let's start with this first example, y equals x squared minus 5. So we're going to start by addressing the transformations, and we want to be able to write out all of our transformations. So if I look here, I'm looking for all of my letters. If there isn't a letter, so if there isn't an A or A is just 1, I don't talk about it. It means it hasn't changed, so I just leave it. So our first one here, y equals x squared minus 5, the only thing we have here is my k, which is minus 5. So from above, we know that k will shift our whole thing 5 units down. Now, if my vertex was originally at 0, 0, and it's been shifted 5 units down, that's the only transformation that's happened, my vertex should be living down here at 0, 5. Now, we need to address our step pattern. So I first start by finding my vertex. It's going to be down at 0, 5, so I can graph that part quickly. There it is. And next I need to figure out, how do I move from my vertex? And that is where I use my step pattern. So we haven't talked about step pattern in a while, but our original step pattern is always over 1, up 1, over 1, up 3, over 1, up 5. Now, because my a value is just 1, there's no a value in front of my x, I just use my old step pattern. So what I'm going to do is I'm going to go over 1, up 1, and then I put a nice dot. Then I go over 1, and my next number is 3. So I'm going to go up 1, 2, 3, and put a dot. Then I go over 1. It's always over 1 no matter what. And I'm going to go up 1, 2, 3, 4, 5. And now that I have my nice points, I can mirror them on the other side of my vertex. Because my parabola is nice and symmetrical, I can mirror these on the other side. So just go over 1, over 1, up 3, over 1, up 5. And I could go further and go up 7, but I think we'll run out of room on our graph. So we're just going to leave it there. And now I just plot my nice points here. And then I'm going to connect it with a nice curved line. Oops, I went a little bit off the line that's on the graph, but that's okay. And then we put little arrows on the end. And the reason we put arrows on the end is that this is just a little snapshot of our parabola. It actually goes on forever and ever and ever. So that is our first example. We'll try a second one. So for our next one, we have y equals 2, x minus 3, all squared. So let's identify some of our numbers here. So we have a little a for 2, and we have an h over here. So we'll start by writing out our transformations. So I first start by looking at a. Has there been a reflection? Is a negative? In this case, no. So there's no reflection. It should be a happy parabola. Next, I notice that there is an a value. So not looking at the sign, just the number, I notice it's bigger than 1. So we should have a vertical stretch of 2. Next, I'll address the h. So I do have an h, and it appears as negative 3 in the equation. So when it appears as negative in the equation, it means I'm moving 3 units to the right. So remember with h is it's a little counterintuitive. So we're going to be moving to the right. Next, we're going to look for our vertex. So we're going to think about where our vertex was. Our vertex was at 0, 0, but we've moved 3 units to the right. So my little vertex is going to move over 1, 2, 3, and my new vertex is going to live right there. So let's plot that point. Now, we can write out our vertex here. We're at 3, 0. Next, we need to address our step pattern. So, has the shape of our parabola changed? Because we have an a value, it has changed, and we wrote that it was stretched by a factor of 2. So going back a few lessons to lesson 3, when we had a stretch or a compression, we had to multiply our step pattern. So that's what we're going to do. We're going to take our old step pattern, which is up here, and we're going to multiply everything by 2. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10, 7 times 2 is 14. And it's unlikely we'll be able to fit all of this on the graph, but we'll do our absolute best to fit what we can. So now that I have my vertex, I'm going to use my step pattern to move from that point. So you're going to put your pencil onto your vertex, and you're going to move over 1. That doesn't change. We always go over 1, and then we go up based off our step pattern. So in this case, we're going to go up 1, up 2. Now again, we go over 1, but this time we go up 6. 1, 2, 3, 4, 5, 6. And that's all we'll be able to fit on the graph, so we'll just leave it there. Now, because parabolas are symmetric, I can do the same thing on the other side. So I go over 1, it's always over 1, up 2. Again, over 1, up 1, 2, 3, 4, 5, 6. And now we're going to write out all of our points, make them nice and dark, and then we're going to connect them with a nice curved line. Here we go. And you can really see the stretch here in comparison to the last one. Our graph is much taller and skinnier, so we know that it's been stretched. So that's our second one. Let's do another one. This one has everything put together, so it's a really good example. So let's start by identifying all of our letters. So we have A in the front here with a half. We do have an H as our 6, and we have a K sitting at the end. Now let's start by listing out our transformations. So the first thing we look at is our A, and we look to see, is A positive or negative? So because A is positive, we know that there was no reflection, so we don't need to write that. Next, we see that just the number, so our absolute value is 1/2. So that is between 0 and 1. So we know that we have a compression by a factor of 1/2. Next, we'll look at our H, and in the equation, we'll notice that it appears as a positive 6. So when it's positive, it's counterintuitive, we're moving to the left. So we have a horizontal translation. Six units to the left. Next, we'll look at our K, and we have a K value of -3. So remember, our K is for a vertical translation. And because K is negative, we have 3 units down. Okay, so let's find out where our vertex is, and then I'll show you a bit of a shortcut to finding our vertex. So our original vertex of our basic parabola lives at 0, 0. Now our vertex has moved 6 units to the left. 1, 2, 3, 4, 5, 6. And then our vertex moved 3 units down. 1, 2, 3. So our vertex lives right here at -6, 3. Now there is a bit of a pattern in the equation, and you can always start like this if you want, find out where your vertex was, and then begin. But there is a bit of a pattern. So my H is always going to be my X of the vertex, but with the sign switched because we're moving in the opposite way. And my K will always be my Y of the vertex. And you may have put that together last lesson, but it is really helpful to find your starting point. So on our graph, we have our vertex here at 6, 3. Sorry, -6, 3. And now let's use our step pattern to figure out where we move from there. So in this case, our A value is 1/2. So we take our original step pattern and we multiply everything by 1/2. So we originally had 1, 3, 5. I just don't have room for the 7, but you can put the 7 if you want. And we're going to multiply everything by 1/2. I'm just using decimals right now to make graphing a little easier. So 1 times 1/2 will be 0.5. 3 times 1/2 will be 1.5. and 5 times a half is 2.5. So graphing with decimals like this is tough. Do your best to get as accurate as possible. When you're graphing by hand, it's always taken into consideration that you can't get decimals exact. So just do the absolute best you can. So we're starting from our vertex. Remember, put your pencil on your vertex, and then you move over 1. And this time we're only going to go up 0.5, and that's where we'll put our dot. Then we move over 1 again, and we're going to go up 1.5. So we're going to go up 1 and then 0.5. Then we go over 1, and this time we're going to go up 2.5. So we're up 1, 2.5. And because our parabolas are symmetrical, we're going to do the same thing on the other side. So you put your pencil on your vertex, over 1, up 0.5, over 1, up 1.5, and over 1, up 2.5. And now that we have all our points, we're going to connect them all with a nice curved line. And you can see now that compression, because my graph is definitely wider and shorter than my other ones. Okay, one more example. So again, we're going to start by listing our transformations. So the first thing we always look at is our A. So in this case, our A is negative. So that means it's negative, it's unhappy, should be a sad parabola, which means it opens down. So in other words, we have a reflection in the x-axis. Next, we want to address if there was a stretch or a compression. So we look at our absolute A. In other words, ignore the sign, just look at the number, and we have a 3, and our 3 is larger than 1. So we have a stretch by a factor of 3. Next, we need to address H. So I look, and we have a positive 3 in our equation. So our H is telling us we have a horizontal translation, and we are moving 3 units to the left. So again, we're going left because it's positive, so it's kind of counterintuitive. And finally, our K. Our K represents a vertical translation. And in this case, we are going 4 units. And where are we going? We're going up because it's positive. So we're going to find the vertex both ways so you can really see where it comes from. So we're going to start by finding it from the equation. So remember our H with the sign switched is going to be the x part of our vertex, so we'll have -3. And then our K value is the y part of our vertex, so we have 4. Now let's do this graphically so you can see why that happens again. So our old vertex of our basic parabola starts at 0, 0. And then we moved 3 units to the left. So we went 1, 2, 3 over here. And then we moved 4 units up. So we go 1, 2, 3, 4. So our vertex should be living right there, which is exactly what we got from the little shortcut method. So whatever is more comfortable for you, you will need to get to a point where we can look at our equation and be able to just find the vertex without graphing it. But I do find graphing helps you to get there and helps you to really understand what's going on. So now that we have our vertex, we need to start figuring out our step pattern. So remember, we always take our old step pattern from our basic parabola, and we multiply it by whatever our A value is. So in this case, our A value is 3. So 1 times 3 is going to give me 3, 3 times 3 is going to give me 9, and 5 times 3 is going to give me 15. We definitely won't be able to fit all of these on the graph, but we'll just do our best to get as many points in as we can. So again, we're going to use that step pattern to find the rest of our points. So you put your pencil on your vertex, and you're going to move over 1. But this time we've had a reflection. So this is a sad parabola, so we're expecting it to be facing downwards. That means that when we draw it, we need to take that into account. So instead of going over 1 and up, this time we go over 1 and down. 1, 2, 3. So remember, because of that -3, we're moving down. Next, we go over 1 again. Now we're going to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And now, because parabolas are symmetric, we can do the same thing on the other side. So we go over 1, down. We're going down because our a value is negative to account for that reflection. Then from there, we go over 1, and we're going to go down 9. And the second side is a little bit easier because we can follow the first one. Now we just connect them, draw my points a little darker, and then we'll connect them with a nice curved line. And again, you should be able to notice that stretch here. Our parabola is a lot taller and skinnier than the past ones, and that's because of that 3 living in front of our equation. So those are our examples. Now what I want you to do is there are some other ones below. I want you to give them a try and complete this worksheet below and write out the transformations. This lesson is very, very important for grade 11. So go through and do the absolute best you can and fill in all the answers yourself and then check your answers online.